Okay, this is the second video I'm doing to show off a platform called SIEVE. I've done another video in showing the SIEVE Builder. SIEVE is a platform that's built by the University of Melbourne and the CSE of Spatial Collaboration. If you haven't seen the Builder video, you should watch this before you're watching this video. So in this video I'm showing the SIEVE Viewer, which can show 3D landscapes, and where I'm sitting here is on a farm that has been affected by climate change in maybe 30, 40 years time, and we're sitting on a farm of a traditional farmer who has not changed the way he's managing his land. And what we can see is that this farm is affected by drought, and this has affected the stocking rates of the sheep. So he has less sheep than he used to have. Let's walk around. So you can see you can import an area from the GIS, as I've shown in the first video. And this area here has been imported from the GIS. So we can go into flying mode as well and fly around the landscape. And these little flags that you can see, they were used as part of a presentation where people were basically guided through this simulation in a demo. So when we move over here, we can see that there is a second farm which now has adopted several changes to cope with climate change. Firstly, we can see the grass is a lot greener. That's due to the fact that the grass that's been growing here has a lot deeper rooted roots, and so it can cope with the changes a lot better with the heat and drought. And stocking rates of the sheep are a lot higher. So if you go back to walking mode, we can see that there are more sheep here. This farmer also has diversified, and over here we have a little tree plantation. Let's fly a bit faster. Which we can see here. And over here is a biozone to establish some natural habitat for native animals. And over there in the distance you can see a little reservoir that has been constructed to collect water and also as a habitat. And lastly, what this farmer has done is he's joined the community in building some eco-energy plants. So here's a biofuel plant, and in the distance there is a wind turbine farm. This would be seen not that one farm is putting all these wind farms up, but as a community effort. So this scenario you've seen here is a real scenario that has been presented in Australia as a possible future scenario on climate change. Another thing you can do is just bring up some graphs. So here's some underlying graphs that show where the scenarios are coming from. So here we have some yield model predictions. Okay, here we are in another scenario that we built automatically from GIS. And you can see here we're in a cornfield that also has been affected by climate change. The corn is not as dense as it used to be. Whereas if you go over to the field over here, the corn is a lot denser. Just go into flying mode. So in this scenario here, we have some cattle grazing over here, and in this corner we have a pine plantation. Another set of capabilities that we have is that rather than showing the real world, is showing icon-based worlds, where we're not showing how it's really going to look like, but put icons in to give some other sort of information. In this case, farmers might want to know what the productivity of the land is, and we just put these wheat barrels in there, showing that here it's low productivity on the land. And as we go along to the other farm, we have a lot higher density, so the productivity here is a lot higher. So it's another way to visualize a farm and can give the farmer a good idea about the productivity he can expect. We can not only vary density, we can also vary size as well. This is yet another scenario which is a completely different area, and in this scenario I want to show that we can not just look above ground but also underground. So here you see some great trees growing. We are in a riverbed here with some saline grasses growing, and if you want to know what the water underneath is doing, we can simply clip the foreground away and now look underneath, and the yellow areas mean that the water is not very close to the surface, and at the red spots here the water is very close to the surface, and the stippled grey areas mean that the water here is saline. So for example, in this area here above the ground we would expect a highly saline or salt coming through the surface. So if we go back here, we can clip that away, we can move through the landscape and have a look at another spot. So that's orange there, so around about there we should have some more salt. We can also move the plane so you can see how it slices through the terrain, and move that back if we wanted to. Or if we go into camera mode, we can also dive underneath and have a closer look. So that opens up a whole new area where you can connect underground data to surface data to see how these two are related. SIEVE also provides a lot of other functionality. We can edit the objects on the surface. There's an inbuilt editor. It's also a collaboration environment, but all of that I'll show in a different video.